Hi, all. Warm welcome on behalf of Furniture Education. I hope you all are doing well. And topic that we will have a look at today is from FRM Level 1, Paper 2 Quantitative Analysis, and it's from Reading Machine Learning and Methods. And we will look at overfitting and underfitting via one example. And yes, you will get a sense that your thought process is stimulated, and this is something which is required from exam like FRM, wherein your actual concepts, intuition of concepts are tested. Let's look at the question and then we will understand this topic, and then we will try to answer this. So there is a quant analyst who has been contracted by a significant investment company. There is an investment company to classify all the companies listed on New York Stock Exchange into either profit making or loss making categories. He gathers training and validating. So basically, three important terms. When you use machine learning, you first train machine using some data, then you validate, and then you use it for your actual prediction and forecasting on ML based models. The data consists of 2000 observations of listed companies, each consisting of 30 features. So you have 2000 observations to train your model. And one important term, like if you see here, like feature and target. So in normal econometrics, how we have y and x being independent and y being dependent. In the same analogy, in machine learning, we do have feature and target, wherein feature is something you can think of this as a like x analogically, and target is as y. Like this can be your feature and this can be your target, or you can just simply say input and output. Like these are the nomenclature used in the machine learning. The quant analyst train his model, like training his model using this data. Observe the trained model is good correctly classifying. So on trained data, he noticed that the model is correctly classifying profit making or non-profit making. However, the model does not perform well using new data. So when you test on the new data, it doesn't work well. Which of the following is most likely to have a distorted model? So you need to identify this problem wherein the model works very well on the trained data, but poor on tested data. That is the new data. So this is tested data, and this is your trained data. We are given this information and we are given four options to identify which problem is this. So before we like answer this, we need to understand like what is overfitting and underfitting. So let me just so before we answer the question, we need to understand what is overfitting. So overfitting, if you like, I can just write some bullets on the PowerPoint and explain it to you. But sometimes visualization helps you understand concepts better. So these are the two plots from Python which will help you understanding the concept of overfitting. So if you look at this black dots, it says train data. So these are your actual observations. Say for example, like inner question, the company's profit or loss. Say for example, we have noted these are black dots here, and what you do, you try to fit these like to train your model. You try to come up with some curve. When I say come curve, it could be polynomial or anything. So you try to come up with like how we have in linear regression is equal to y equal to x plus b. In machine learning, given it can handle complex data also, you try to come up with some polynomial. Say initially you came up with polynomial of degree 3, which is blue line here. And if you go further higher, like if you come up with some polynomial of order 10, it will fit. Let's say for example, these two black dots here were not captured in blue line. Blue line was like it was not capturing these properly. This red line, it captures these red lines like almost all the dots as much as possible. If you go further higher, it could be like the curve may look like this also. Like you may come up with curve which is exactly capturing this. But yeah, that would be somewhere around 30-degree polynomial, like just hypothetically. So the point I'm trying to make over here is overfitting is like if you go further higher, say if you come up with some say 50-degree polynomial, it will capture all the points. So more complex you go, more like your model will work best for your training data. But what the problem is, like you can think of these as like the rankers of the class who can do very well in academics, but when they are actually tested in the practical life, then they there will be outliers. So this model is performing very well on the trained data. Like you can think of this as the rankers of the class who score well, but in the practical applications, like there are outliers. So the overfitting is a problem wherein models are super complex, wherein your data fits so well in the trained data that when you apply this model on the testing data, it really fails and you have higher variances. So when you talk about variance, you talk about how model is in train versus trade testing data. This is how the variance is talked about. We will cover variance and bias aspects in the following slides, but just to I didn't highlight the problem with overfitting. It would be higher variance. So in overfitting, you have very high variance. Over there, like it will work well on the trained data, but it fails on the testing data. Not really fails, but the performance is not that effective. So yeah, this is a testing data and this is a training data here. Similarly, we can talk about underfitting problem, wherein you can just again the data is same like what we had during overfitting, but what you do, you pick some simple model like linear regression, but it will like you can see that the fitting is like not that great. You rely on model a lot, that assume that your model will capture everything, but it doesn't really. So this problem wherein your model is so simple that it doesn't work well on the training data, this problem is called as underfitting. And in underfitting, like you can notice here, like in underfitting, the variance is low because like anyways model was not performing within training data. It doesn't work for testing data also. So we say variance is low, but because you rely on model high, you say it is a very high biased. So bias towards the model is quite high. In overfitting, you have higher variance. In underfitting, you have higher bias. This is something you need to remember, very important from the exam point of view. In fact, this question can be answered by now. Like we can answer this question right away with this amount of information. And yeah, so this is a linear fitting wherein your model is very simple, your data is complex, you're using very simple model. That problem is called as underfitting. You assume that your simple model will work well. You can yeah, that's how underfitting works. And nextly, like whatever I just explained, I have like if I would have shown you these bullets earlier, perhaps you would not have followed, but given I shown you visuals, now it would be very easy for you to understand. So if you look at bias, the error introduced by approximating a real world problem which may be complex with a simple model. Your data is complex but you're using a simple model. There you talk about higher bias, like how we talked in case of underfitting. So in underfitting, bias is quite higher. High bias means that model is making strong assumption about the data. Like in this case also, your model assume that your data follows your linear pattern, but it really doesn't. Like you can see very well, see from the picture only, you can see it's not really linear, it's a curvature. So in bias, your model assumes make the strong assumption about the data. And when we talk about variance, your model sensitivity is quite high when you like as I explained that on trained data it works very well, but like your model is quite sensitive. On your model works very well for trained data, but it doesn't work well for tested data. High variance means that model is highly sensitive to small fluctuation in training data. Like as I said, that if you change the training data slightly, your model fails and poorly performs on the new data. So this is how the bias, variance, and overfitting, underfitting are defined. And this was variance and bias, what we know about that. And now let's talk about overfitting. As I explained, occurs when model is too complex. You fit your data very closely by using some complex model, and it's too large because you're trying to fit each and every point on your data set, and has too many parameters because you have to go to higher degree polynomials to fit your data. This is evident when new data causes the model perform worse. So if you apply new data, or if even if you change trained data also, your model will not perform, or even tested data. This is a greater risk when you talk about machine learning models. So for ML, the overfitting is a problem, and for econometrics model, conventional econometrics model, underfitting is problem. And underfitting occurs when model is too simple and fails to capture the relevant patterns. Like as I said, the data was curvature, but you are trying to fit it using the linear regression, so it will not give you the great predictions. So to summarize, overfitting air variance because it works well on trained data but doesn't work well on the tested data, and low bias because your model works very well on the trained data. And on the other hand, for underfitting, you have got low variance because it performs well on trained data and tested data. So we say it has low variance. But bias is high because your model assumes that your linear, like the simple model, will capture the complex data. That's why we say with underfitting, bias is quite high and the variance is low, because either ways it will not work well for trained and tested data. So this is about overfitting, underfitting, and variance and bias aspect of these problems. So if you go back to our question, like we were given a key information that your model works well for trained data, but when it was applied on new data, it failed. So this is a clear indication of overfitting with higher variance, because trained data versus tested data problem is there, and this problem is overfitting, and it has a higher variance. It really, overfitting does not even have a bias problem because your data worked well on the trained model. So the correct answer for this question is D. That's how it works. And let me just show you how these plots were plotted, what you see on your screen. Just allow me a moment. See, what you see on your screen is overfitting problem that I was showing you, that the real data, how you fit the model. And if you notice here, like the mean squared error, it's a basically tool used to quantify errors in your model. So with a 3 degrees, it was around 1%. If you increase the degrees to polynomial of degree 10, it went further down. If you increase the polynomial of degree 20, it will further go down. Whereas if you go up and see what we had in linear model, like you try to fit a complex data using linear model, but it really gives you the big error. Over here, if you notice, the mean error is quite high, around 20%. So this problem is underfitting because you're using simple model for a complex data. So these can be done in Python, and let me just go back to PowerPoint. So if you are really interested in applying things, like, see, perhaps you could have understood and answered the question and went ahead, like perhaps in exam you would have answered it correctly. But if you are really interested and keen to apply things in your practical world at workplace, then we have something to offer on Python. And this is something which our institute is offering, like Python for financial professionals. It's a very basic course, like these problem machine learning things that we talked about. These are advanced. If you're interested, and like if you make a good progress on basics, then you can go for these complex ones as well. But yeah, these are the tools that are actually used in the market So it's worth learning these tools. And we do have like the good courses on these. So get in touch with our teams, WhatsApp on the numbers that is shown below. And please don't forget to subscribe to our YouTube channel. And yeah, please do subscribe, and thank you for staying till the end of the video. Thanks for watching. Yeah, please do subscribe and share with your friends, peers who are like in the similar domains. And perhaps if these tools or these knowledge are helpful for them, please do share with them. Thank you.